The availability of economical worldwide travel by air was made possible by the invention of the jet engine. Modern aircraft engines are engineering marvels, simple, powerful, and best of all, reliable. In such an engine, most of the entering air is accelerated by a fan and bypasses the core. The core flow is first compressed in the compressor, then is heated in the combustor, and then expands in the turbine, which powers the fan and the compressor. Hot gas from the combustor blows directly on the turbine. This requires that the gas temperature be limited to avoid damage to the turbine. The future of high-performance jet engines depends on creating energy more efficiently. The temperature of the gas must be raised beyond today's current limits. Future solutions must apply advanced technologies that will enable the temperature of gas to be raised without exceeding the limitations of the turbine. The scientists and engineers at NASA Lewis Research Center have been working on a device to relieve this temperature limitation. The device is called a wave rotor. In the past, wave rotors have been used as a source of high pressure and temperature air for a very high-speed wind tunnel, and as superchargers on diesel-powered vehicles. The main thrust of the efforts at NASA Lewis Research Center is the application to aircraft engines. A wave rotor consists of a rotor which has air passages mounted on a drum and which rotates. It's enclosed in a housing. Air is brought on and off by a set of ducts. Entering air from the engine compressor gets compressed to a higher pressure inside the rotor passage by a set of waves. It then passes to the combustor where it is heated. Returning to the wave rotor, it expands to a lower pressure and temperature before being discharged to the engine turbine, now at a lower temperature than in the combustor. The whole unit would fit into the jet engine where the combustor sits. Because the combustion takes place at a higher pressure and temperature, the engine produces more power, up to 20% more, while consuming about 14% less fuel. At NASA Lewis Research Center, a three-part program exists to develop wave rotors for jet engine applications. The three parts are theoretical calculations to explore the physics, experimental work to demonstrate its performance, and system studies to examine the benefits of various wave rotor applications. Theoretical calculations are used to simulate the flow field inside the wave rotor so that researchers may better understand the inner workings of the machine. The theoretical calculations are carried out using state-of-the-art computer programs which were developed at the Research Center. A unique feature of the wave rotor is that gas dynamic waves are used to compress and expand the gas rather than a mechanical device, such as the blades of a turbo machine. The proper control of these gas dynamic waves is essential to the wave rotor's performance. Researchers can predict the propagation of these waves accurately by using the computer programs. We are now looking at an example simulation of the gas dynamic waves in a wave rotor of the type which could be used in a future gas turbine engine. Inside a laboratory at NASA Lewis, an operating wave rotor was constructed. This experiment will provide important information on the performance of an actual wave rotor. This information helps researchers validate the theoretical calculation needed to predict wave rotor enhanced engine performance levels accurately. Finally, applications for the wave rotor are being explored, which might include increasing the power of aircraft and helicopter engines and reducing the fuel consumption of auxiliary or secondary power units, the engines used to provide onboard power. In the near future, the team at NASA Lewis Research Center hopes to take the first step to demonstrate wave rotor technology in a jet engine. The Wave Rotor Research and Technology Program is another example of how NASA is working to improve America's transportation system for you.